My hope is that we do. I want to get at least these three that people have already asked about. But there, we've done about 4 to 5, if not more, questions in all the other classes. I'm going to post them online here in about 20 minutes. So there's about 80 to 90 minutes of class examples that you guys can kind of sift through and see if they help you. My suggestion to you, every time you do one of these problems, highlight the 3 parts that are allowed to be geometric means. They're allowed to go in those mean locations. Those are the only 3 parts that can go there. Okay? And what goes in those geometric means, in those spots, does not have to be a variable. Okay? I've been working with a lot of people throughout the day, and they keep saying, well, X is what I'm trying to solve for, so it's got to go here and here. No. What goes in the geometric means are one of those 3 highlighted segments, right? Does that make sense to everybody? And you should be able, especially depending on the amount of things that they provide you, to write 3 proportions for every single question. And that's where your homework's going to be tonight. I'm going to ask you, I'm going to give you about, I think, 15 questions, and you should be able to write, for about half of them, 3 separate proportions. Okay? This one, because I don't have any algebraic expressions for the green, I don't have 3 proportions, I'm going to have 2, right? So let's look at y. What kind of segment for the overall triangle is y? Is that an altitude or a leg? I'm going to call it a leg, and it's actually a bad question the way I phrase it because it's both. Okay? But it's not an interior altitude, right? Okay? It's not the yellow one. So a leg is the geometric mean, so it goes in those 2 spots. Okay? Now, between the what and what? What should go here? The whole hypotenuse. So that is your whole hypotenuse, right? Which is 9. And now the part of the hypotenuse that is touching that leg, which would be that, right? So 7. Okay? So, y squared will equal, okay? I'm going to write it this way, guys. I'm going to go 9 times 7. Okay? Because when I take the square root, it's this, right? Which we know can be written that way, right? And why do I do that? What kind of number is 9? It's a perfect square. And 7's prime, right? Okay? Those of you that do, go ahead and multiply that out. And you get 63. That's fine. What are 2 numbers that you know for certain multiply together to give you 63? 9 and 7. Do you see that we just undid that multiplication? And then you can take the 9, obviously, and go down to 3 and 3. There's your group of 3s. That created a 9, that created that 3. And there's your 7, that creates that 7. Kind of see the comparisons there? Okay. Now we want to solve for x. So x is the altitude that is on the inside, right? Okay, so that's going to go here and here. Now what would I put here? 7, right? It's got to be, it's the part of the hypotenuse. And then what goes here? 2, the other part of the hypotenuse. Okay? Cross multiply, you get x squared is equal to 14. X then is root 14. Maybe here's a thought. If I want to see if that simplifies, if there's a perfect square that divides it, the perfect squares I have to check are less than what number? How about this last couple days? Half of 14, right? Which would be 7, correct? Well, it's the only perfect square that we know of that is non-trivial. 1 is a trivial perfect square. So non-trivial 1 would be 4, right? Does 4 divide 14 evenly? Nope. Okay. So what that tells me is that when I do the prime factorization of 14, there are no pairs. Okay. That's something we can do? So that was 12. 13. Again, I'm going to go through. I'm going to highlight the three things that are allowed to be geometric means. And it's those three things. It's always the three segments that start at your right angle, right? I'm going to look at the yellow one. Do I know what the yellow one is? No. We actually do have enough information. If I wanted to call it Z and solve for it, I could. I don't know why they don't ask you to in this question, but it is what it is. Let's look at X. Okay, that's the interior altitude, right? Okay, so just focus on that. X is going to go there and there. Now, what should go that spot there? Or what could go there? The interior altitude is the geometric mean between the... Okay, 72 is an option. So if I put 72 there, what's going to have to go here? 8. Okay? We talked about the other day when you're looking at this green segment. Okay, we're trying to look at the total number of parts that we look at kind of form that T, don't they? Okay? So that tells us to use the 72 and the 8. All right, now here's what we're going to do, x squared. Now I get 72 times 8. Now I'm just going to check something real quick. If I type in, 72 times 8, let's see if I've got a calculator open somewhere. $72 times 8, 576. To me, that's a pretty unique number. Okay. When you take the square root of that, you get 24, right? Okay. So 576 is a perfect square. Okay. So that's a situation where I would really multiply those together. Usually what I do is I always got my calculator next to me, right? Or do a little bit of mental math. If I see it, this becomes a nice number. Something maybe I've seen in the past. I know then I'm going to try to take square root of that, and in this case, it gives me 24. Okay? But let's say I didn't know that. Let's say I didn't take 576 and hit the square root key. Maybe I use the technique that I showed you earlier where I know 72 times 8 is going to be a big product. And I don't like dealing with factor trees of big products. So let's do this. So that means square root of 72 and square root of 8, right? Okay, what is 72? What are two factors for 72? 9 and 8, aren't they? There's no really wrong answer there, but why did I choose 9? What kind of number is 9? Yeah. Okay, so 9 is going to be, the square root of 9 is 3, right? Now, what's a square, how can 8 be broken down? 2 and 4, right? So maybe that 8 breaks down that way, and the second 8 breaks down that way, right? What's the square root of 4? 2, so I got the 3 here, got the 2 there. What's this one? That's going to be 2. Okay, so now you're left with radical 2 times radical 2, right? Well, what's radical 2 times radical 2? Yeah, those two things end up being radical 4, right? What's radical 4? 2. What's 3 times 2 times 2 times 2? 24. Okay. Again, is the calculator a little bit faster there and checking to see if I get 576 as a perfect square? Yes. By all means, use that. But you have to be able to address, what if it gave me 575? Now what do I do? Because that's not a perfect square. Okay? And this might be an approach if you got a number that wasn't a perfect square. And I think we see that with y. So let's kind of solve here for y. So y is a leg. So it goes there and there. Now, it would be the geometric mean between the what and what? Or what numbers? What number could go here? Okay, 80 is going to go there because it's the geometric mean between the hypotenuse and now the part of the hypotenuse that touches that leg, so it's going to be that 8. Good. So y squared is equal to 80 times 8, right? Okay. if I go y is equal to radical 80 times radical 8, okay, let's say maybe per square that divides 80, anybody know? How many nickels will divide 80? If I had 80 cents, how many nickels would that be? $16, isn't it? 16 times 5? Okay. And then this 8 is, we know a radical 8, we've seen that enough. That's 2 radical 2, right? Because it's got a 4 in there to divide. So what's square root of 16? 4. Okay, what's this? Now we got this 2, right? Now we got radical 5 and radical 2. So what's 4 times 2? What's on the outside? 8. What should go on the inside? 10. So 8 radical 10 is the same thing as radical 640. Think about it this way. If I did multiply, and I kind of paused at the beginning because I was kind of fighting the urge to do this, because this is how I would have done it. I see y squared is equal 8 times, I don't see that 0 right away, right? What's 8 times 8? 64, and that's a perfect square, isn't it? So when I do multiply this, I get 640. Okay, well, isn't that the same thing as y squared would be 64 times 10? Now square root of 64, square root of 10. What's square root of 64? All right. A lot of different ways of doing it, and the more you force yourself to be exposed to it, you work with them, and you work with them in varying ways, the better you're going to get at these. Okay. I know it's not, if I had options, okay, I would sit at home and watch TV too, play video games and all that kind of stuff. But when you're trying to prepare and try to learn how to do this stuff, it might be a good idea to maybe waste 30 seconds, 40 seconds, and do it one way and say, okay, what if I did it this way? Do I get the same answer? Because if you do, you just taught yourself something. You just learned something. Does that make sense? Okay. Do 17 real quick here. All right, so this one, we've got x plus 21. It's the altitude on the inside, right? So x plus 21 goes there, and x plus 21 goes there. Now, what should go here? And we got that interior one. We're trying to look at that t, right? So x is going to go here, and maybe 84 there, right? Okay, so when I cross multiply, I get 84x. And now, what's x times x? X squared. I'm going to get 42x's, right? Anybody know what 21 times 21 is? What? 21 times 21? I heard it. 441. Okay. Now, and all of these, depending on what your numbers were, all these are kind of, once you get to this, they all kind of fit the similar format. You're going to subtract 84x from both sides. So that's going to be, then give me negative 42x plus 441. The way these were all designed is that this number here will always be twice as big as that number right there. Okay. But now, when I factor this thing, I'm looking for two numbers that multiply together, give me 441, and add to give me 42. Didn't you just give me two numbers that multiply together, give me 441? 21 and 21, right? If I add those together, do I get 42? So it's going to be negative 21 and negative 21. So what's x going to be? X is 21. And it shows up twice as an answer, so we want to write it down once. And you guys can check. You can check yourself. Now understand that the check only works for the algebra. I'm only checking the algebra. I can't check right now because I don't have enough stuff on the triangle. I can't check whether my proportion was right for the picture, But I can check that based off what I wrote here, that I did all this right. Because if I put 21 right here, and I put it down here, and then I put it up here, does that go to 1/2? Does that go to 1/2? So that's the check. 1/2 equals 1/2. Okay. I'm going to do a question with you tonight from your homework real quick. So let me pass this out, and then we'll do that question. All right, so at the top, those directions, don't worry about those. The Math Excel thing, I don't have that set up the way I want it to be set up yet. So don't worry about that component to it. You do probably want to write at the top to simplify everything, simplify all radicals. We want that practice. But I want to do number 1 with you, okay? For a couple reasons. One of the reasons is when we read it, they say find JM, right? So if I'm finding JM, do I know what it is? No. So what should I let it be? X. So all of these things here that they say find whatever, those are your variables. Let them be X, Y, whatever you want to be. Okay? Now, it's the same picture for every single one of these. So you might have to redraw this a couple times. Okay? But they're saying find JM. So I'm going to write X there. They tell me LM is 4, and they tell me MK is 8, right? Does that look like the little T that we've talked about, right? It's upside down, but still is that shape. So which one of these is the geometric mean? What number? 4. Okay? That's why I wanted to go over this, because predominantly I get people with those parts to say, because it's just the examples we've seen so far throughout the last couple of days, a lot of times the variables go there, right? It's not the variables that are going there. Those aren't placeholders for variables. Those are placeholders for either that segment there or the legs of the right triangle. Does that make sense? So then X and 8 can go there. You can cross multiply and you got your X. Okay? But what I want you to understand is that your geometric means do not always have to be variable objects. Okay? They can be numerical, they can be expressions, they can be whatever. Okay? So finish that up. There are a couple on there, and just kind of noting 12. You're going to get some decimals that terminate, so that's fine. Number 10. You're dealing with some fractions in the picture, so the picture starts you off with fractions. Your answer should probably end with fractions. Okay? That's going to make you think a little bit because you got now fractions with radicals and rules about that. Give that a shot. We'll talk about some of those tomorrow. My hopes are to move on to 7.5 tomorrow as well. Spend the next about day and a half on 7.5. And then on Friday is your test over chapter 7.